record it just in case anyway. All right. So you have a piece of netting that you're going to make a compost bin out of, which is a circular thing. Now, if you have it taller than it is wide, does that give you a bigger volume? Or if you have it wider than it is tall, does that give you a bigger volume? Which scenario is going to give us a bigger volume? Well, let's figure it out. This piece of netting is 60 on this side. So if you wrap it around, 60 is the what of it? Is it the radius, the diameter, or the circumference? If you wrap it around, it's the circumference. So, Jack, lid shut. Thank you. So, the circumference equals 60. What's the formula for circumference? 2 pi r. So if I want to figure out the radius, what would you do? If I wanted to figure out the radius, divide by 2 pi. Nope, I did not say area. So the radius is equal to 30 over pi in this situation. To find the volume of a cylinder, what's the formula? Pi r squared h. What happens is it's the area of the base times the height. Because let's say you have a little round disc and a whole bunch of them. If you stack them on top of each other, you can find a three-dimensional volume. Okay? One little disc, the area of it, the area of the circle, is the area. And then when you stack them up, then you find a height. So the volume equals the area of the base times height. So 30 over pi is the radius. So it's pi times 30 over pi squared, radius squared, times the height. Well, what's the height in this situation? 100. Okay, so what's 30 squared? 30 times 30 is 900 over pi squared times 100. So it's 90000 over one of these pi's cancels with one of these pi's, 90,000 over pi, if you put it that direction. Okay? Now let's put it the short fat way. Okay? So, what's the circumference if we lay this down? So the circumference equals 100, which equals 2 pi r. So how do I get r alone? Divide by 2 pi. So r is going to be equal to 50 over pi. What's the height going to be? 60. So the volume equals pi r squared h. Pi, the radius, is 50 over pi squared times 60. What's 50 squared? 2,500 over pi squared times 60. So if we take 2,500 times 60, what are we going to get? A big number. So it's 150.
15 with 5 zeros. That's 4 zeros.
4 zeros.
No, mine says 5. Oh, I did go wrong.
Okay, so it's 150,000 over pi, right? Which is the bigger volume? The short fat or the tall skinny? Short fat is. Okay? So, that's finding volumes of objects given certain information. Okay? Now, an oblique prism versus a regular prism. All right. So, here we have a regular prism. It stands straight up and down. Here, we have an oblique prism. What's special about an oblique prism? It's crooked. It's leaning. It's like the Leaning Tower of Pisa. Okay? Now, Pisa, not pizza. Uh-huh. So, the oblique prism. The volume of a leaning prism is the same as the volume of a straight up and down prism, as long as they have the same base areas and the same heights. Okay? So, if we have, nope, we're not going to do vocab this chapter because this is the only section really with vocab. So, all right. So, if you have a bunch of paper stacked on top of each other, they are the same amount of paper. If you push them over to make them leany a little bit, the volume of papers will not change. It's just they're leany instead of straight up and down. Okay? The volume of papers will be the same. So, an oblique prism, if it has the same base and the same height, so this is Cavalari's principle. If an oblique prism has the same base area and the same height, then it'll have the same volume. So here's an example. Here's two round canisters. Okay? What is their volume? Well, there's one of them's an oblique cylinder, the other one's a straight up and down cylinder. Now, which height should I use? Should I use the straight up and down height or the slanty height, which is the slant height? The straight up and down to find the height, to find the volume. So the volume of a cylinder is the area of the base times the height. What's the area of the base? Well, what's the radius? 10. And the height is 25. So it's pi times 100 times 25. So it's 2500 pi if we put it in terms of pi. And they're both going to be the 2500 over pi. They're both going to have the same volume. Okay, so the volume, if it's a prism, whether it's a triangular base prism, a square base prism, or a hexagonal base prism, it doesn't matter. It's whatever the area of the base is times the height. Whatever the area of the base is times the height. Now, if you have a cylinder, it's the area of the base times the height. But what we do is we make our lives a little bit easier by knowing that the area of a circle is pi r squared. So we take pi r squared times h. Now, how much firewood can that guy fit in that triangular firewood shaped thing? No, not too much.
Already in there, so you can just count it. Yeah, one by one.
You.
It'd be
All right,
fun.
so the volume of firewood in here. Now, what's the base of this firewood thing? Is it the bottom, which is 6 by 2, which is 12? Or is it the area of the triangle? It is the area of the triangle is your base. Okay? So, when you have prisms, what do you see that the sides are made up of? What shapes? Rectangles. Rectangles. The sides are all rectangles. So the sides of this are rectangles. So this is the side. So this is the height. So you got to basically lay it down. Okay? It's a laid down triangle with a height of 2, and you have to find the area of the triangle because the volume is the area of the base times the height. Well, the volume is, the area of the base is 1/2 of 6 times 4 because the area of a triangle is 1/2 the base times the height. It gives us the base all the way across and the height 4. So 1/2 the base times the height is the area of the triangle. The height of the prism is 2. So 1/2 of 6 is 3. 3 times 4 is 12. 12 times 2 is 24. It has 24 cubic feet. Why is it cubic feet instead of square feet? Because it's three-dimensional. Feet times feet times feet is feet cubed. All right. So, when we do problems today, there'll be actually real life problems, problems that you could possibly solve in real life, such as Marta had little kids. Kids are gone, they're grown up, they're out of school. So now she wants to take the little sandbox they used to play in, and she wants to make a garden out of it. Smart Marta. All right, so she's going to figure out how many of these bags of soil she needs to buy to fill up her sandbox with soil to make a garden. Okay? Now, what are the dimensions all measured in for the bags of soil? Inches. So we have feet up here. Is it easier to change 5 inches into feet or 4 feet into inches? Much easier to change feet into inches. So this is 48 inches by 48 inches by 10 inches. So the volume of this is the area of the base, 48 by 48, by the height, which is 10. Calculadora, por favor. Because it's 4 feet. If it's 4 feet, how many inches is that? 48 inches.
23,040 bags.
Not 00, just 23,040.
I added 100%.
You did. Okay, now that's the volume of the box. Now we got to figure out the volume of each bag to figure out how many bags she needs to buy. They basically are. Yeah. So when you lay them down, they squish into a rectangular prism. All right. So they're 10 inches by 18 inches by 5 inches thick. So somebody, calculator, take 18 times 10 times 5. How many times does 900 go into 23,040?
I tried, Joe. It is 25.
What do you do? Add, subtract, multiply, or divide? You divided. So we had to divide, and we got what? 25? 25.6. How many bags does she need? 26 bags to fill it so it's leveled off across the top. Okay? So,
She could just get a baby bag.
all right. Catherine uses juice to fill a cylindrical pitcher. So she has a little pitcher here. Okay, there's a cylindrical pitcher that's 11 inches tall, and it has a radius of 4 inches. Then she has little cans that she's going to dump into there. How many little cans of juice that are 6 inches tall and have a radius of 2 inches will fit into the big pitcher?
What's the number on the side?
11. So, to find they're both cylinders. What's the volume of a cylinder, Jack? Formula. It's right there. What's the area of a circle? Pi r squared. So it's the area of the base, pi r squared, times the height. Okay? So it's pi times 4 squared times 11. And leave it in terms of pi. So it's 16 times 7, which is 176 pi. Okay? The little cans. What's the difference of the formula from the big pitcher to the little can? Nothing. They're both cylinders. So it's still pi r squared h. Pi times 2 squared times 6, which is 4 times 6, or 24 pi. How many times does 24 pi go into 176 pi? Add, subtract, multiply, or divide? Divide. So she needs 7.3 cans?
Yeah.
But she can't buy 7.3 cans. So 8 cans would overflow the pitcher. So 7 cans is going to maximize her volume in there without overflowing it.
She could literally just dump in.
Okay?
She could just water it out. She could just water it out.
Jeez. All right. So if you find the volume of each, hey, if she has a big container which she scoops out laundry detergent, and how much laundry detergent is she going to pour in? Find the volume of this, find the volume of this, and then do what? Divide. Thank you. We're not going to do that problem. All right, but we're going to do the neon Tetras problem. Benito has 15 neon Tetras in his aquarium. Each neon Tetra requires at least 2 gallons of water. What's the maximum number of neon Tetras that Benito can have? So then, how many neon Tetras does he have to flush down the toilet because he put too many in there? Because all drains lead to the ocean. What movie? Finding Nemo. Good job. All right. So the volume of the aquarium, what's the radius?
It's 16 and a half.
So it's 8. What's 2048 pi? It's 2048 pi, but since we have cubic inches equals gallons, we need to put the pi involved in there. So you have to take 2048 times pi to get the actual volume in cubic inches, which is? All right. So, how many gallons fits into that aquarium if each gallon is 231? Tyler, pay attention. So if the container holds this many cubic inches and there's this many cubic inches in a gallon, what would you do? Divide by 231. So take this, divide by 231. What do you get?
If you don't round to the pi, it's exactly
28 gallons.
You're a liar. If you don't round the pi, if you keep it as 148, he wants all of his
Shh. Shh. All right. So each fish needs 2 gallons of water. So how many fish can fit in there? 14 fish. How many fish does he have to flush down the toilet?
75.
1.
Can you guys read? That is so sad. Oh my god. Can you like give him a call and tell him I'll take his neon?
Okay. It is a Friday, so we need to get going. So I will leave you with that.